um, I think it was Knative and serverless, right? I personally haven't worked with it. I have personally seen that, and there was this one scenario with Knative where, let's say that you have built an application, and in the basic principle behind serverless itself is that everything sits idle, and only when a request is fired is
Mhm.
when all of them come up and running and are active, right? So when you try to do the same thing in regards to
Yeah.
Kubernetes using Knative and so on, what exactly happened with one of our use cases was that, okay, I'll possibly put it in a different perspective. How is Lambda fired? How does
Mhm.
Lambda work underlying? So Lambda is powered by something called as AWS Firecracker. And AWS Firecracker is a customized software-based layer that was written by AWS. It uses KVM based virtualization. It runs on bare metal
Okay.
instances. So you have a bare metal instance over which you run Firecracker project to create something called as micro VMs. And let's say that you go ahead and put it into a for loop in terms of programming. You have multiple micro VMs running at the same time. All you have to do is
Same
in
time.
regards to constraints for memory and CPU and so on, right? So this is how at the end of the day Lambda works. Lambda is powered by AWS Firecracker, and the other project that is powered by AWS Firecracker is ECS Fargate. Both these projects are
Yeah.
powered by the same tool in the background, but they are run on these unused instances or probably bare metal instances, which AWS has in their data centers dedicated towards Lambda and ECS Fargate kind of workloads. Now let's bring that same concept into Kubernetes. Let's say that when you work with the cloud and you work with some kind of stack where you have API gateway triggering a Lambda function, inserting data into DynamoDB or RTS or whatnot, only when that API gateway's request is fired, then only a Lambda function is triggered. Until then, that micro VM is non-existent. Only when that request comes into your Lambda function is a micro VM created. Lambda also does support Docker images, so which means your code is packaged and run on that micro VM and given a response back to you on the Lambda console with your logs in CloudWatch. And then whatever that Lambda function does is up to that Lambda function. When you think about the same, let's replace that Lambda function with a Kubernetes pod. So
Kubernetes.
Knative's principle behind that is you have a request that creates a Kubernetes pod in the background of your application, right? And your request is a service at the end of the day, which is exposed as a load balancer or exposed as node port, or on top of that service, you have something like an ingress that is exposed to the outside world with a domain name mapped to your Route 53 and so on, right? So only when you hit that domain name and your respective path-based mapping, does it go to that respective service. Your pod is non-existent at that point of time. But once your request is fired, your pod starts up. The biggest problem in regards to Knative is that the one that I felt from last time, because it's not yet mature, I don't know the industry-wide adoption of Knative, is that your pod takes a lot of time to start up, and then your application has to start up within that
Uh,
pod.
Within the pod.
So in that way, let's put it this way, that Lambda was far more better optimized because AWS sat behind it for a very long time. And in that way, Lambda has this cold start the first time, but then every other request goes to that same container instance, which means or that micro VM, it's warm startup. It's already there. But then after some time it's destroyed, which means
Mhm.
subsequent requests would also be cold started, right? Probably the 10th request or the 20th request and so on. So it depends upon the memory configuration that you give Lambda. You can give all the way up to 10 GB with the recent update. Depends upon the memory configuration that you give, that your micro VM stays for that amount of time. If you give 256 MB as your memory, it stays only for very less time. It's destroyed immediately. But we couldn't do that with pods for applications because your network request itself would wait for a long time before getting back a response. So which means your application would keep on be loading, loading. You would see nothing on your page. So for application workloads, the last time that we tried Knative, it was not that great. But then, yes, it would have become more mature. I'm talking about 1.5 years, 2 years before when we tried this out. So, but anyways, yeah, that's your answer. I think I've given it enough justice. Hacking hacker. Yeah,
Yeah, yeah. Like it was pretty much good in explanation and the intuition behind the how cloud native works and why we need to adapt it, why not. Yeah, it's what pretty much good.
absolutely. And when we go with something like programming languages like Java and so on, each and every microservice that starts up takes 2 to 2.5 minutes, depending upon whether it has to talk to an external system like an ActiveMQ or it has to talk to a database. and it has to run some queries, it
Yeah.
has to then start up. It usually takes 2 minutes to 2.5 minutes. When you run these application workloads with Knative, how long will your pod wait in terms of, or your application or front end would wait in terms of getting a request? It just doesn't make sense. Yeah.